I'm going to be talking about full stack test automation. So
Awesome. I'm
yeah,
very excited for this. So I'm going to go ahead and pass it over to you.
okay, great. So hello everyone. Have you ever had a task of automating everything on UI end-to-end test automation layer? Probably you thought that, oh, yes, I'm gonna have work cut out for me for a long time because that's a lot of work. Or maybe you were thinking, is it the best layer to have full stack of test automation on? Well, in this talk, we're going to be talking about the full stack transformation, not like one layer who's responsible for automation, but like how can we utilize every layer we have in our control to actually have a best test automation solution ever. So let's dive into. So throughout this whole presentation, you're going to be hearing a bug filter concept. So basically, it's just an idea how we can structure our test automation layers. So it would be just like a filter. So we're going to go through, our application will go through those filters, and some of the specific bugs in each of the layer are going to be picked up, and we're going to have distilled version of application free of bugs. Well, that's theory at least. And we can't talk about automation without thinking or touching the testing pyramid, right? So this is the one, like this is written by Mike Cohen in a forgotten layer of test automation pyramid. So, and it was trying to produce like or promote the layer of service layer because a lot of like UI testing was happening and testing was happening, but service layer not so much. So he wanted to promote that, but yeah, eventually this evolved into something else, something bigger, like test pyramid. Automation was dropped from there, like manual testing happening. A lot of other layers it was put into that. Like there's even one for machine learning again. And when people look at this, they are knowing that they need to write less UI tests than unit tests. So basically, this is some kind of a ratio layers, how we can structure our test automation. But is it a good like strategy? Can you use it as a strategy for every UI test? I need to write two API tests. Does it make sense? So it's a nice output of your testing strategy, but it doesn't fuel you like how you can approach automation. But there's another one which might be more useful, and this is the bug filter by Noah Sussman. So his idea is that you have infinite set of possible known bugs, and this is an application with infused bugs. And then you run through unit test layer, you basically can pick up some of the bugs. And by unit testing, you can test in backend, like server side. You can test logic, behavior, some kind of like actions happening behind the scenes. Also, there's unit tests on client side, like all the modern like frameworks have them, like Angular and React. They have unit testing capabilities, such as like if you have a form, you can take that component and you can test validation for each of the fields. You can test the form submitting, like is required fields are if you're not filled, are they disallowing you to submit that form. Also, if you select something from a dropdown or a checkbox, another field might be becoming disabled. All of that can be tested in unit test layer. That's much faster, and you don't need to write end-to-end tests for each of those cases. So by utilizing that, you can probably sort out and find majority of bugs in your application, combining UI and backend tests, unit tests. So when you utilize that layer, some bugs can't be caught with unit testing. And this is when you go to the integration layer. There is something like how the backend and client side actually integrating. Is it working as a holistic approach? Is a database working? Is the components inside the application working and behaving as you expected? So those are requiring integration kind of tests to make sure that they are working and they're still don't have any bugs. Later, you can reuse end-to-end test for the bugs you can't find with unit and integration test, but only for to find those specific bugs. And this leaves us with not so much cases to cover because a lot of things have covered in unit test and integration test. And what's happening if you are covering the same thing, like the same logic, same acceptance criteria, both in unit test and in end-to-end test? The thing is that unit tests are running first. So if you have a build, it's built and it's actually tested. That means that that bug going to be found in that stage and it will not go past it. It will not be deployed to environment where we can run end-to-end test. It will need to be fixed first, before it proceeds. So basically that bug will be fixed before end-to-end tests even have ability to catch them. So if you write the same thing, cover the same thing on end-to-end test as a unit test, the end-to-end tests are, well, useless. It's an extra cost, it's an extra maintenance, it's extra thing to care about and actually prolong the duration of your whole automation suite. So if you can avoid to actually adding more tests into end-to-end layer and add more into unit test, that would be more, well, smarter decision to do. And by doing this, you actually end up with this perfect pyramid of like testing layers, because you only cover everything on unit test, on only what's not covered with unit test, you cover with integration, and then with end-to-end test. And at the bottom of that layer is the human testing. So when you run all your automation, the human testing steps in, and they can find edge cases, specific bugs, maybe some like callers or like accessibility bugs, all of the things which end-to-end test and like all the rest of the layers can't find. So you might be thinking, well, I've seen this before. Yeah, it's kind of depicting this like anti-pattern of ice cream cone, but this is different layers. Like that on top layer is a manual tests, and then the biggest layer of testing pyramid is end-to-end test, and the lowest one, the smallest one, is unit test. In this one, it's still the normal test automation. Like this pyramid, these layers are still the same as before. We're just thinking about like from bug perspective. But let's take another look at this from the top. And from the top, it might look like a bug net where we have some kind of a coverage with unit tests. So they're covering some parts of the system, but there's still gaps. And we can come up with this test from like checklists, from acceptance criteria, from user stories, from behavior, and we can check them in unit test. When developers are finished, then usually test engineers can start working on some kind of end-to-end tests. And they usually assume that nothing is covered in unit test. Like that doesn't exist. So we need to do everything from scratch. So we're duplicating the same effort. We're still using the same source for our unit UI test. We use checklists and we use acceptance criteria. And we end up with this one. So probably you can't see, but if I zoom good enough, you see that there is an extra line of the yellow one. And this is end-to-end test. We're basically duplicating the effort. Yes, we're adding a little bit of coverage with system level like tests, but it's not that much. We're testing the same thing. And if there's a bug in this specific acceptance criteria or checklist, unit test will find them first. It will never reach end-to-end test layer. So that will be, well, useless. So what we should do instead is that actually trying to find what's covered with other layers like unit test and integration test, and then write appropriate API and UI tests to cover those gaps. That would be the most useful thing we can do. Not to overlap and duplicate all the effort, but just smartly think what can be tested with other layers. And we just add just the things we need, not more, just what we need. And this brings us to the full stack transformation approach. It's the same pyramid, but what we do, we synchronize all the layers. They kind of aware of each other, what's covering what, and we only write the ones we need, extra ones. And usually this pyramid looks like that, right? From responsibility perspective, there's UI test, there's API test, and unit integration. Unit integration, well, they are kind of developer responsibility. They write the code, they write unit test, and integration test. That's it. Rest of them usually fall into test engineers and QA's responsibility to maintain and develop. And the worst thing about it, that usually there's a really big gap between those. And even like a wall, like we don't care what unit tests are like testing, we mistrust them. Also, developers don't care what other layers are testing. And well, frankly speaking, they shouldn't. Their goal is to write as many coverage in unit tests as it's possible, and the rest layer should be actually integrating in what's already covered and like thinking about it and only covering what's extra. So basically, it's test engineer responsibility to look what's already covered, and then design the API and UI tests which are like covering the gaps, not like all together, like duplicating everything. And maybe you have seen this before, like when API tests are smaller than UI tests, and you have more UI tests than API tests, or none of API tests as well. Like I've been here. I like thought that if we have one framework, why should we have two frameworks to support? Like, why do we need API testing? Let's do everything on UI. What can go wrong, right? Yeah. So sticking back to this idea, so test engineers, if they want to keep that responsibility of API and UI tests and still be efficient, they need to start thinking what developers are doing. And that's actually not that hard because these two areas are already merging. Developers are doing unit tests. That's kind of a testing. They following checklist, maybe using checklist before we submit that, like finishing the user story. They do code reviews, and test engineers as well. They're moving to developer perspective. They are using more sophisticated tools, which require scripting and developing. Maybe some areas like security testing, performance testing, those are requiring more and more technical knowledge. Also, they're writing end-to-end tests and API tests as well. This requires scripting, sometimes even multiple languages and like various ones. So test engineers do going into that area as well. And in that union, really interesting things happen. Then people who are like both know test engineer perspective and developer perspective can come up with the solutions which are well unseen of, like outside the box for any of those other areas. We can't see those solutions, but this person who knows both of these areas can come up with this. And like full stack transformation, it might not make sense from developer perspective and also test engineer perspective, but somewhere in between could come up with this idea. Like full stack transformation is not a new thing. It's like it's been talked about for a long time, but it's not like maybe not in similar name, but it's not a new theory. But people are coming up with that, and like usually the generalists who are both can do developer and test engineer perspective can come up with this idea. So we need to start moving to developer area more and more. So why don't we look at the unit tests? And this is one of the examples. And they're usually really small, really checking like atomic, checking one functionality only. And you probably seen this before. It's like really familiar. The it framework, like assertions, all of that are used from other frameworks as well. Like Jest is using the same thing. Like it's really familiar. And if developers are writing proper function and method and variable names, it's really easy to read that code to understand what it's actually doing. So we can move up a level and maybe look at the whole suite. Filler, firm settings, detailed component. There's a few sections. One of them is basic. Should create. Okay. There's another section for init. Should assign filler, firm settings. Should call. Yeah, it's kind of complicated, isn't it? And the thing is, why it's happening is because developers, when they write unit tests, they think about the code. They look at the code, they look at the variables, which are changing by the functions, by the methods. Then they look at the methods and how to call them, how to run them. Because one of the main reasons to calculate what's the coverage is unit test coverage. And this is actually, if you mistreat it, you can run into really big problems. Like if you look at the code, in this specific example, it's like there's a function and it takes one array and there's like 3 variables there inside of it and bool value. So basically, in order to test everything, this is the whole like array you need to use of test data in order to check everything to have 100% coverage. But if you look at it not from functionality perspective, not from acceptance criteria, not from a checklist, but just as a plain code, you can end up with only 2 of these. Like you run everything with true, and you run everything with false, and you have 100% coverage. This functionality might not even been working. These 2 test cases might not be even existing, and you will have 100% coverage. And this is one of the criteria to pass your code reviews, to have at least 70, 80, 90 or more percent of coverage. It doesn't mean anything. There might be not even any offer asserts there. Because how code coverage is working is that there's some kind of a watcher for every line of code, and you run your unit test, and basically saying yeah, this line of code was executed. It doesn't have to be asserted that it's working. It just have to be executed. If there's no internal server error, that's fine. That's it. This is working. So there's a lot of caveats with this unit test coverage and a lot of things that can go wrong. This is why we as a test engineers, we need to go and help developers to develop better skills in writing tests. They have to think about the functionality. Maybe this is some kind of like permission layers. Like there's permission to view dashboard, to view sales, to view reporting. Maybe that true is not existing. That's not actually user. Maybe super admin, maybe. And false, that doesn't exist. at least one permission have to be in there. So if you think from functionality perspective, that might be a different story, how much you need to test, how much is actually tested. But it's not all bad things with code coverage. There's a good things as well. Like it gives you really good information of what's not covered. So basically, if you have like a set of tests which are testing behavior from checklist, you basically run those and you can look at what lines of code were not tested. Maybe you forgot some kind of edge case. Maybe you forgot some kind of like critical functionality, which you, oh yeah, that was existed as well. So you can write more test cases based on what's not covered. Or maybe that part of code is, well, never used. Maybe you just need to delete that and don't keep it in the code. So a lot of things from what's not covered can come up out of from code coverage, but what's covered, it doesn't mean a lot, actually. It could be nothing. So coming back to this example, so we basically were looking at the code, what the methods are, what the variable names are, and we were changing variables, doing something with code without actually understanding what this means, how it actually affects the system. So this is not a test cases, this is more like, you know, our variables are working, our methods working, but for end user, it doesn't mean a lot. So this is another example. And this is both of these are from actual projects in our organization. So this one is also UI unit test, like client-side unit test, more like integration one. But anyway, so here's like team capacity forecast report, and there's a few sections, one from plan hire, one from employee, and then plan hire should take planned hire date from newer capacity, should correctly resolve plan hire department, organization unit, and competence. Well, that makes sense. If I would be working in that project, if I had the domain of that project, I would understand what we are actually testing. I could use that when developing what other test cases I need to have in API or end-to-end test layer. And actually, this is a snippet from a comment inside the user story. When developer finishes developing, like implementing it, he's posted a snippet of what unit tests are written. So test engineers can look at that, maybe come up with edge cases, come up with more cases, maybe come up with like sharing their checklist beforehand. And so that could be added into this coverage as well. So you as a test engineer, you can bring so much into unit testing just to help, just to ask good questions like, what is this actually testing? This will help them to think like, I don't know, but maybe you should know what you're testing. Maybe you should could use some kind of user stories to come up with the testing, maybe checklist. Maybe you can help them come up with the good test cases. So one of the exercises you can take for next time to start your journey into like looking at what unit testing is, and you can look at the bug fix. For next time you will have a bug fix, you go to the pull request and you look at what have been changed. Is there any unit test written? Is there anyone like all the unit tests changed so they would find that bug before it's actually introduced? So the thing is that if you have a bug, that means that coverage, which is like in unit testing or integration layer, wasn't good enough. There was gaps and bugs occur. So maybe every time when you have a bug, you should have unit tests to find it first, and then fix this bug, and then you will be able to move on further. Why specifically the bug fixes? Because well, it's a really small scope. Like it's a few lines of code usually, and then unit test. It's easy to understand to have a greater like scope what's actually changing. If you take 13 point story point user story to actually go and check how units are written, that might be too much, like multiple classes, multiple lines of code. This just might be too much to start this journey. So you should start looking at those pull requests and looking at unit tests. It's not that hard, and you can actually do a lot of good for the project and cut the scope from automation if you can cover that in unit testing. So getting back to the actual full stack transformation, how can it work in reality? How can we utilize all these layers and keep them synchronized throughout the whole project? So option A is the developers are writing unit and integration tests. Then they know what we covered already and what's not covered, so they can write API test if it's required, and then write UI test if it's, again, required. Option B is the developer writes unit test, integration test, and then writes specs of like specifications of what needs to be covered with API and unit tests, UI tests. Then the test engineer come in and according to a specification, write the missing tests. Option C, developer saying like, you know what, it doesn't sound like my responsibility, or it doesn't sound like my problem. I'm just gonna still write the unit test, but you will need to go and analyze what's been covered, do the extra work, and then create the missing API and UI tests. So the whole table would look like this. Option A is, well, the most efficient one. There's no carryover, there's no transfer of knowledge, there's no bottlenecks. One person starts working on it and it can finish that. The rest of the options are more complicated, but they're still doable. So there might be option D. Like right now in the project I'm working in, how we approach this is that we have a lot of legacy code, like something that we inherited. And we have the pages like prioritized, like which are more important. We start with that single page. We'll look at what the functionality is there, like what the functions, what the user expects to do. Maybe there's some kind of checklist. We come up with every test case we can think of, like what can go wrong and what needs to be working for this specific page. And we split into what can be tested with unit tests, what can be tested with backend unit tests, what can be tested with API and UI tests. And then we look at what's already covered and then add those missing unit tests, API tests, and end-to-end tests. This is how we can still, even for legacy code, approach this full stack transformation and don't overlap a lot of testing. So this can help us not slow down, but fasten the way how we can change this page, cover these pages. So when we finish with one page, when we move, implement everything, then we move with another page from the highest priority list. For the actual things that we are working right now, like new functionality, for backend developers, their responsibility are to write UI and unit and integration tests, and also if they need to write API tests, which are required by, if they think that it's required. For front-end developers, they need to write unit and integration tests as well. But if they see that they need to another layer, they can use end-to-end test. Basically, that end-to-end test, they don't need to use it that much. It's just for new pages that it's accessible from UI. It like the page is loading. Maybe there's the table. The table is displaying the data that we need, and that would be the end of end-to-end test. Everything else, like logic, everything can be tested with unit integration test. So this is how we can build up this full stack transformation approach, even with the different teams. And test engineers can help with each of these layers and each of the test cases. So maybe there is another option which would work in your specific project, with your specific skill set and your teammates. So it's really depending on what the approach you're going to take. So looking back at this bug filter, there's another piece. Like on the bottom of that, after all the automated tests, there's a human testing. So it means or it implies that you need to run all the automated tests you have before you start human testing. Because if the end-to-end test or integration or unit test can catch that bug before you have to check it out, find it, and then report it, it's easier if they do that. So if already that is written, you should use them. So how to utilize it even more? This specific human layer is that human testing layer is the parallel builds. This is just an idea which we can use in this modern age. So there's pipelines which are each of a build have to go through, and one of them is to deploy to some kind of environment and run automated tests. So if you have multiple builds and only one environment, you will need to wait a long time before they actually checked, and it could be a really big bottleneck depending on how long does it take to run all the regression suite. So what you can do for that, instead, you can use this modern tool set of Kubernetes containers and actually ask Orchestrator to build you an environment whenever you have a new build. So you have a build, you ask for Orchestrator to create your environment, you deploy all the newest version to it, and then you run API and UI tests against it. If you have another build, no problem, create another environment and dynamically create it, and then you don't have a bottleneck. When it's finished, it's finished. So that what it helps you is that it have constant time when it's finished testing. If it's an hour, that's fine. It's going to be finished after 1 hour when you launch it. If you have this one environment, that might be 5 hours if you have 5 builds piled up. So in this one, you will have it in 1 hour all the time. So what you can do is that every time when you have a pull request created, you can launch this. You can start testing that pull request, like that build, before you finish the code review. So that might take more than an hour, and you will have a feedback from all your automated tests before that pull request is finished reviewing. And this would increase the return on investment on the whole automation because you will be running it more often, not only nightly when you have time, but on all the builds and only when they passing. And if it's have really great coverage, you will have a lot of information that that didn't break any kind of functionality elsewhere. So you can just focus on the current new functionality. So it's a nice theory. We haven't used it yet, but it's something that we probably should start thinking. If we don't know about it, when we can come up with that idea. But if you knew about it, you can ask your DevOps engineers or infrastructure engineers to actually come up with this solution and make it work. So this brings us to the summary. And one of the first items I want to reiterate that this automation pyramid, that static model ratio, it's not the strategy, it's an outcome of a good automation strategy. Bug filter might be a good strategy because it allows you to focus not only like the functionality, like I need to test everything. No, it's more of a risk-based approach when you think of what can go wrong, what are the places which might be affected, and what I need to test to make sure that it's still working. So if we have, for example, we have a page with a table where there's displaying the inventory items in warehouse, then another page displaying items which are available in the store, and the third page which are already sold. This might be tested from like automation perspective. All of them can be tested separately with data, with the logic, how we move items from one list to another. Like if it's sold, it should be in another list. You can do that, yes. But if you can think about what can go wrong, you can start thinking like, hey, this is the same table. This is like same component reused from all of these 3 pages. And if we can test it separately, like I can add column for text, column for amount, column for percentage. I can do sorting, filtering with that. I can make sure that it's working on unit test on the client side, unit tests before, like I don't need to write end-to-end test, expensive ones, to test that functionality on each of the page. I know it's the same component. Why don't I just test it separately? Then from API perspective, I also know that it's the same endpoint, just different filters, like what type of items you should return to that. You can test that with API tests. You can ask them to return a specific list, then in the backend change something like sell something and make sure that it's actually working. And then all the logic, all the edge cases, all of this like transfers, like how the items are operating, you can test in unit test layer easily. So this will save a lot of scope. Will save a lot of unnecessary tests. If you can think of this like from bug filter perspective, what can go wrong and how can I prevent that? So this will still require you to look at the unit test. You need to understand how they work, what are the capabilities of that, and how you can utilize that. And well, someone should take care of a full stack transformation. If there's no owner, you will still have that wall where you don't care about each other, what tests are written in unit tests, what tests are written in API tests. You need to come up with like owner for that. Maybe you yourself can be the owner who will synchronize all the layers and make sure we are moving on like more effectively rather than just like recreating all the coverage. And you need to remove bottlenecks from your pipeline. If you see something that's like blocking you, like we're living in really modern age where the tools are so advanced that we can just probably we can't come up with all the use cases we already can solve this. We just need to think of that, how could you utilize that? Because if we remove the bottlenecks from pipelines and we can run end-to-end test and API test on every build, that would increase its return on investment. So it would be easier sell to invest more into automation because we're running them on every build. It's like giving us value not only nightly or not only before release, but on every build. So yeah, with that, I think that's it. Thank you for listening. If you have any questions or success stories or how you're actually implementing that in your organization, I would be glad to hear that. So you can contact me on LinkedIn. So yeah, and maybe any questions.
Thank you so much. That was fantastic. So there are a couple of questions in the chat, and I've got some thoughts for you as well in case no other questions come in. But please, 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 if you have a question, drop it in the chat so that we can answer it live. So Julia says, thank you for the great talk. How do you communicate to devs what should be tested? Constantly checking their PRs, or maybe use test cases written in business language? Or what process do you recommend?
Yeah, well, one of the ways how we solved it, or trying to solve it, is that we talk about what should be the coverage, how we should look like from moving from code coverage, moving into more like behavior coverage. And we asking test engineers to provide checklists before the like implementation is started, so they can maybe even marking which could be a perfect unit test. And then developers can use that when for unit testing actually purpose. And I think by giving them feedback over the time, they will get like, because like this idea, like I was surprised how much, like how acceptable they were to this idea, because it makes sense to not duplicate everything. Just like you need to know what you're covering in before those tests, and then cover like gaps, not like everything from the beginning, not duplicating everything. So they're person who are like people who knows like numbers and like rules and algorithms, we will get it, and we were gonna do something to help you out with that. So it's really easy, and like I think it's like I love this collaboration aspect. Like when you don't, like when you helping them, they helping you to understand the unit test. You giving them feedback. They're like helping you to write better end-to-end tests and API tests. It's just such a great collaboration. I think this is one of the like hidden parts of that. So it's not, there's no golden rule to do that, but you need to communicate and then talk about it and maybe help them out. Maybe have a good arguments how to actually implement that. So I'm not sure if it's actually answered the question.
I think you did.
Yeah, thanks.
And when you talk about shifting away from code coverage, I completely agree. I've had more conversations than I can count lately about how little value code coverage actually gives us. And I want to, and I hope you agree, shift the conversation from code coverage to value coverage. Have we covered what delivers value? Because code coverage is arbitrary. Value coverage means that we're delivering something that matters. So I don't know, just something I thought of. Julia also asked if you could make some recommendations on your favorite API testing tools.
Well, it's there is no favorite. Basically, in the current situation, how we like, because we want to shift API testing for developers, backend developers, we usually need to synchronize with what we're using, so we would be more comfortable. If it's like C#, then maybe JavaScript wouldn't be the best framework to use for them, but there's a lot of like tools out there. Axios is like very often used in like, and I use this as well, so it's one of the better ones. But it doesn't have to be a rule. It's just a helper to you. Like there is like idea and approach is more important than tooling. Like this isn't like an agile. Like people and like this is more important than tool. So.
And the API testing tools you use are really going to depend on if this is for you, Julia, as a tester, and maybe you're new to API testing, you may want to choose a tool that has some learning built in. If you're really advanced and you've been doing this for a long time, you would maybe use an IDE. So, because some people say like, you know, this particular tool is my favorite, but I think it depends on what you're doing, right? And where you are. I want to give a last chance for questions before we shift over to our next talk. Actually, I think we have a little bit of time. I think we might be ahead of schedule. Yeah, we do have a little bit more time. Do you have any?
We started early.
We did start early. We started early. Do you have any other kind of thoughts you wanted to share?
Whoa, okay, you caught me off guard. I hadn't anything prepared yet, but
That's okay.
yeah, I think like this idea of like curiosity. You need to be kind of curious. You need to go and like try to make sense of things. Like if you're afraid of something, like unit testing is so scary. I don't understand what they're doing in there, but like you should try at least. You should come up with the easy steps, how you can go to that, try that experience before you like giving up doing that. But so curiosity is one of the things that would allow you to grow as a specialist. Like, what about this one? How about this tool? How about another tool? How about this approach? What's new in the market? So you're always going to find something interesting and will allow you to grow as a specialist, and you would be, well, you would be ahead of a curve, I guess. So that's always good.
And if this is new for you, and I'm speaking as somebody who went from zero coding to a little bit of coding, even if you don't do it, like even if you have no experience, go sit down at a group code review, be a part of it, because you'll pick things up. It'll give you that chance to be curious.
Yeah, yeah, that's a good point, starting point. Yeah.
Thank you so much. That was great. And I think there's a ton of takeaways. I think people are going to go back and rewatch this. I'm going to go back and rewatch it because, I want to see it a second time. And I especially love that you brought in Noah's diagram that he uses, because I'm a big fan of his work. So thank you
Yeah,
so much,
yeah.
Nikolaj.
Thank you for having me. It was a real pleasure, and have a nice rest of the presentations.